Hello, Coach Travis here with another calculus video. So this is an antiderivative initial value problem. The idea here is they're giving us a derivative. So they told us the derivative of this function y, and they basically want us to find the value of the original function. So they're telling us the derivative of y, and they want to know, well, what's the formula for the original y before you found the derivative? And then what makes it an initial value problem is that they gave us this little bit of extra information about the function. They told us that when the x value is equal to 3, then the output is going to be equal to -5. So that's what this is meaning right here. Basically, that's how I would translate this expression here. I would translate this into being when x is equal to 3, because x is the input, then y is equal to -5, because y is the output. So all right, so basically they're giving us a point on the graph, and they're giving us the derivative. And from that, we're supposed to be able to uniquely identify what the function is. So all right, so how are we going to do that? Okay, so first we start off with the derivative part. So I'm just going to rewrite it so I can get in the spirit of things. So they told us that dy dx is equal to -4 cosine of x minus 3. And so I need to figure out from that, I need to basically undo the derivative. I need to reverse the derivative and just get y back. And my favorite way to do most of these problems is by guessing and checking. So when I think about derivatives, I think, like if I want to get a cosine, like if I want to get a cosine out from my derivative, I think that I probably want to start with a sine. So what I'm doing over here is I'm guessing and checking. So I'm going to guess, I'll start with a guess of the sine, and then, well, it shouldn't just be the sine of x. I think it should be the sine of x minus 3. And okay, and now let's check. Okay, well, so how do I check? The way I check is I just find the derivative. Because if this is the right guess, then, well, let's say y. Y is if that's the correct guess, then this equation should be satisfied. And okay, well, let's check it. So if I find the derivative of both sides, I get dy dx on the left-hand side, and I get cosine of x minus 3 on the right-hand side. And so that's close, but if I look at what I wanted, I wanted to have a -4. I wanted to have a -4 out there in front. And I think, oh, okay, well, I could fix that here. What if I just put a -4 right there when no one's looking? So if I put a -4 right there when no one's looking, well, the derivative, that's a constant multiple. So the derivative is going to just let the -4 hang around, and then I will get exactly what I want. So this is kind of the art of guessing and checking. So I encourage you to practice guessing and checking a lot, because it really is one of the most valuable problem-solving tools that we have. So the way you guess and check is just make some guess. Just take your best guess, and don't worry if it's right or wrong. Just try something. Get something down on paper, and then check it. And if it works, great, you're done. But if it doesn't work, then stop and say, okay, well, what didn't work about it? So like in my case, I was missing the -4. And so then I thought, and then so identify what the problem is, and then think, well, how could I fix that problem? So our problem was that we were missing the -4, and an easy way to fix that would be, okay, just put a -4 in try another guess, but this time put a -4 in front, and then it works. So that's guessing and checking. And so if you get good at it, guessing and checking can be a very fast way to solve a lot of problems. Okay, but we're not done with this problem yet. We're only halfway done. Because what we got here is we know, oh yeah, I forgot something here, that when we should know that when we find antiderivatives, we always have a plus c. So what I forgot to put here was a plus c. So now this is more correct. That what we've got here is this, what I've got right here is this is a solution to this equation right here. That you can, we checked that when we did our guessing and checking, that this function right here solves this differential equation. But we're not entirely satisfied because we have this plus c, and that means that I actually don't know what this function is. Like, I can't draw a graph of this function because I don't know what c is. So we need to figure out what the c is. And fortunately, I think we can do that because we have information here that we haven't used yet. We have this information that when x is equal to 3, then y is equal to -5. Aha! So all right, so let's use that information. So I'll just go ahead and make the substitution. I'll say this is saying that when x is equal to 3, y is equal to -5. So all right, so everywhere I see a y, I'm going to write -5. And everywhere I see an x, I'm going to write a 3. Maybe I'll leave it. 3 and then -3 and then plus c. So again, where did those come from? That was y, because y was -5, and that was x, because x was 3. And you can see that follows this pattern here. We should have, inside of the parentheses should be x minus 3. And so if x is 3, then you get 3 minus 3. And okay, so now let's work on this. And well, if you look at this, you can see that we're in good shape because we have a single equation with a single unknown, and that single unknown is the thing that we're trying to figure out. So this is looking pretty good here. So we've got -5 is equal to -4 multiplied by 0 plus c. And so it's not too hard to see then that c has to be -5. C has to be -5. All right, and then we've got our answer now, because we knew what y was up to this constant c that we didn't know. Oh, but now we figured it out. So our final answer is going to be y is equal to -4 times the sine of x minus 3 and then -5. And I'll circle that. So that there is our final answer. So yeah, and this is a good point that I want to make sure that everybody appreciates it, because this is a simple thing, but it could lead to some confusion. We always write plus c here, but c could be a negative number. So the fact that we might be able to subtract something off of this function. It doesn't always have to be plus a positive number. It could be plus a negative number, like we saw in this example, in which case it would be a minus.